Guess what? Guess what today is? Today is Tuesday, and it's time for a Tech Tuesday for IAEI News Live at 12 o'clock Eastern. Today, we are going to talk about, competing design goals. We don't address, in my opinion, we don't address this concept or topic enough. We sort of skim over it. We know that competing design goals exist, but yet we try to figure out how to, we talk about all the different requirements that are either in the National Electrical Code or even in our design goals and objectives, but we don't really talk about how do you handle those when you have a competing design goal. So I'll give you eight goals that, in my opinion, are competing with each other. You have reliability. I can make you a reliable power system. I mean, I can make you a system that will be independent, last forever, but will it be cost effective? So reliability, cost effectiveness, efficiency. In fact, the National Electrical Code will tell you in Article 2, is it Article 220? Here we go. No, Article 90.2. I think this is it. I haven't read it. Yep, it is. I see the word. I see one of the key words. Take a look at your code book. Your code book, I don't care what edition, really. I'm not sure how old, but I'm sure that whatever code edition you are on, this language is in there. And hopefully you're not on like an 1800 edition or whatever. Take a look at 90.2b as in Bob. The title of 90.2b is adequacy. This code contains provisions that are considered necessary for safety, compliance therewith, and proper maintenance result in an installation that is essentially free from hazard. Wow, that sounds like utopia, doesn't it? But there's more. No es todos, but not necessarily efficient, convenient, or adequate for good service or future expansion of electrical use. So I am going to put that in my slide deck. It's a very important aspect to remember that the National Electrical Code, so Article 90 is called Introduction, and I have to, all right, 90.2 is use and application. And then 90.2b is adequacy, and it tells you that you can make this document. It might be that it says these are considered necessary for safety. It says compliance with these requirements and proper maintenance, which is not covered by the National Electrical Code. I mean, I say that installations. Well, let's see if it covers maintenance. Scope. This article covers. That's the article. Let's go to 110. I want to go to 110. So what this tells me is I can meet the National Electrical Code, but it might not be efficient. It might not be convenient. it may not be adequate for good service. And what that means to me is reliability. It may not be reliable. Or future expansion. So if you think about if your facility is going to grow in the future, you don't have, and you met the National Electrical Code, you may not be able to easily or efficiently add in the future. What are these things? We need to think about these things. Make sense? For me, it's one of these areas that we don't talk about. We know about these things, but we don't necessarily talk about these things. And I want to explore this during the IAEI News live session today at 12, from 12 to 1 live. I want to explore these areas. We're going to take a look at 90.2. We're going to take a look at I thought there was something in 110. I could be wrong. I don't think there's anything in 110, but I know there's in 220. So let's take a look at 220. What does 220 tell us? 220 are your branch circuit, feeder, and service load calculations, right? So in 220, there is a table, 220.42a, which used to be 220.12. We moved it to 220.42. Now, if you look at 220.42, there is an informational note. So there's another one I got to put in here. Article 220. Article 220 is titled Branch Circuit, C-U-I-T, feeder, branch circuit feeder, nope, branch circuit feeder. Those branch circuit is not an adjective for feeder. It's branch circuit, it's feeder, and service load calculations. Article 220. So 220.42 is titled lighting load for non-dwelling occupancies. All right, so lighting load for non-occupancy dwelling units, and there is an informational note. And here's what it says. The unit values of table 220.42a are based on minimum load conditions and 80% power factor and might not provide sufficient capacity for the installation contemplated. It might not be sufficient in capacity. That's big, in my opinion. That's big. I mean, just think about it. You are designing your system, you're doing your load calculations per the National Electrical Code, and it's telling you it might not be sufficient. So let's go back to our competing goals. Efficiency is one of the competing goals. You have reliability, efficiency, safety, cost effectiveness. How about scalability? That is, in my opinion, that's the other thing that 220 hits, is scalability. I may not be able to grow my power distribution system easily. If I size my service, if when I start up If when I start up, all I have is a register and a little bit of inventory, but I'm planning on a manufacturing facility, I'm planning to make a product. But right now, all I'm doing is just selling some existing inventory. If I size my system for that function, when I add manufacturing equipment, I'm going to have to increase my service size. Was that scalable? No. Was it efficient? Absolutely not, because now I got to call somebody and I got to change out my transformer from my service perspective. I got to call the utility, I got to resize my conductors, all because I didn't plan for the future. And the code doesn't help me plan for the future. That's something we do as engineers, as designers, as installers, as maintainers. We got to think about the future. Maintenance. I got to think about how I'm going to maintain my equipment. Now we put requirements in the code in Article 110 for working space. What's that for? Working space. Working space is for maintenance. It's for the electrical worker after the fact. Now, if I give the electrical worker a lot of space to work on the equipment, maybe once every 5 years they're going to work on the equipment, is that an efficient use of space? I could argue, no, it's not. Now, is it good for safety? Absolutely. Ease of maintenance? Absolutely. I could make an argument from an environmental impact. I have to build a larger building because of the spaces that I have to provide, because I can't put things in those spaces. Remember, transformers that you put in closets, they're not those electrical rooms are not closets. The electrical rooms are not places to store stuff. If you want to store things, you need to have another separate structure or another separate room. Well, then you might say, well, that takes up space, Tom. That means I have to build a bigger building, and that's not environmentally conscious. Well, those are competing design goals. Performance is the National Electrical Code of Performance document. I could say it is a performance document because it has to perform for safety. We have requirements back in Article 700 that say you have to install a power distribution system in a certain way. And what's that for? That's for the performance. That's for reliability. And reliability, in my book, is performance. So we hit the our 8 competing design goals. Reliability. Reliability is number 1. Efficiency is number 2. Safety is number 3. Cost effectiveness, number 4. Hey, Alan. Talking about competing design goals, brother. I got 4 so far. Reliability, efficiency, safety, cost effectiveness. And then you got scalability. That's like for future growth, environmental impact, ease of maintenance, and performance. Those are my 8 competing design goals. Nihad and I are going to be presenting a tutorial at the Electrical Safety Workshop talking about these competing goals. I can meet a goal, but then I compromise another. Hey, how about this one? Selective coordination. There's a good example. Selective coordination. How is that so what does selective coordination help me meet? Reliability, right? So I take the fault out only in that area of my power distribution system. Is it efficient? I wouldn't say it's efficient. I mean, you're going to have larger overcurrent devices, because what is selective coordination? Selective coordination are intentional delays upstream. So I'm going to have larger overcurrent devices. I'll have larger distribution equipment, possibly. Depends on my design. I could make changes in my design, which is what we're going to talk about during our tutorial at the Electrical Safety Workshop, to make it efficient. Am I increasing safety? I could argue I am both increasing and decreasing safety. How am I increasing safety? Well, I'm isolating only that portion of the power distribution system. I don't have a widespread outage. I'm increasing safety. How am I decreasing safety? I'm increasing incident energy. I'm adding intentional delays. Quite possibly, because if I meet the requirements in Article 700, Article 700 doesn't tell me, hey, Tom, you need to have a selectively coordinated system, and oh, by the way, the incident energy has to be no greater than a certain number. It doesn't say that. It just says I need to meet selective coordination. I got to give you working space based on 110. I got to mark available fault currents based on 110.24, and then also in 408. I got to do all these things, but nothing other than 240.87. 240.87. Hey, Nihad, I'm talking competing goals, brother. Getting ready for next week. So, I don't know if I can do this. Yes, I think I can. I think I can. Hold on. I did something. Oh, there it is. I knew I was going to do that. That's not what I wanted to do. That's not what I wanted to do. How do I undo what I did? Oh, I do escape. Slideshow. Setup slideshow. And I'm going to put it on monitor 2. Okay. And I'm going to bring this down here. And I'm going to go to presentation mode. There we go. All right. Nihad. Join the new live, but I won't be able to. You know what, Nihad? So here's what I'm doing, Nihad. I'm killing a few birds with one stone, buddy. I am, maybe we'll learn some stuff for next week. You never know. Let's see. Does this do it? Yes. Look at that. So those are my competing goals. Long Beach. Oh, that's right. IAS. Enjoy. Tell everybody I said hey there. So I got 8 competing design goals, which I just mentioned: reliability, efficiency, safety, cost effectiveness, scalability, environmental impact, ease of maintenance, performance. We have to balance these design. I'm calling them. I was going to call them design goals, but some code requirements fall in these buckets. Right? Selective coordination is one of those. Working space is another one of those. Is providing enough working space efficient? I don't know. It's definitely safety. It's definitely, I would argue, I could put it in the reliability bucket. I can definitely put it in the ease of maintenance bucket, but I don't think I could put it in the most efficient use of space in my facility. I can say it's probably not the most cost-effective solution because I gotta build a bigger room. I may have to, based upon the changes in 110, I might have to put 2 egresses. Now, we have ways to try to address the cost effectiveness. What do? What we used to do, and they changed the code to say you can't do this anymore, but we used to, instead of putting a 1,000 amp or a 1,200 amp piece of equipment, you put 2 600s. Right? And then you say, okay, I got 2 600s. I don't, A, need to put ground fault protection of equipment. B, I don't need to have 2 forms of egress and ingress to the room, so I can make a smaller room. There's so many things that we do to try to get around some of the requirements. Why? Because we're struggling with these competing design goals. We're trying to make it cost effective. We're trying to make it efficient and so that's what I would say. I would say, oh man, we could have a discussion around. Look, I got my Buc-ee's. So for all you people in Texas, I got my Buc-ee cup. So we can have a discussion around each of these design competing goals and say we can argue which one's more important. It may depend. Man, significant importance. Nihad, this is the cool part about taking the time to walk through these. So we can argue, what do we call that importance? what do you call it when you want something to be more important or less important? It's called, you're not weighting them, your importance. It's not significance. Man, importance of each of the design goals. We want to weight them. What is that? What's that called? What's that called? Let me, oh my gosh, I hate when I do this. What's it called? What is it called when you organize the goals in order of importance? Prioritization. Jeez, oh man. Prioritization. So we'll have to prioritize, right? So prioritization. Now, it's going to vary. Prioritizing these goals is going to be based upon probably the process, right? So if I am in a hazardous, if I am in a petrochem facility, I may not care about efficiency. I may care more about safety and reliability. I may not care about cost effectiveness. I might say, look, I don't care how expensive this is because the product that I'm making is billions of dollars. I don't care if you tell me, hey, this costs $1 million. Nihad, I've got really good connections, so I don't have any drop frames, so it's got to be your hotel. So you may decide safety is the most important, then reliability, then ease of maintenance. I don't know, but you're going to have to prioritize. And I say we all have some sort of priority in our head. You may be the type of person who cares only about cost effectiveness. You might say, look, I don't care about anything else other than how cheap it is. You've set a priority. You've established that over safety, efficiency, reliability, scalability, environmental impact, ease of maintenance, and performance. You may say, no, look, I wake up in the morning and I don't have any plastic in my house. I don't have any, I don't drive a car because of the emissions. You do all these things for sustainability. You changed your life for the environment, for the sake of the environment. You may say environmental impact is the most critical piece of important design goal that you have over everything else. That guides your decision. So now we have to weigh, oh, this is good stuff, Nihad. We have to weigh, yeah, Alan, prioritization. We have to weigh our personal beliefs and priorities with our company and corporate priorities, right? Think about that. Think about that. So personal versus company priorities. You may say, you may have your personal goals might be very environmentally conscious, but your company may not be. Your company might say, look, we know environmental consciousness is high on the list, but safety and reliability are critical. And they could make the argument that safety and reliability are environmentally friendly. Because if I'm a big petrochem, I don't want to release stuff into the air. I don't want to release stuff into the ocean or into the water or into the rivers. So my focus on reliability and safety and ease of maintenance help me meet the goals of being environmentally friendly. You could say these are not only competing goals, but they're supporting goals. I could make those arguments, but it will depend on the application. And we as engineers and designers have to figure out how to balance this. Selective coordination, I'll go back to selective coordination. I like that this example of selective coordination, because I know when back in the day I used to educate a lot before 24087 and 24067 hit the street, which is your arc reduction requirements. I would argue that as I'm putting intentional delays in the power distribution system, the further up I go in the power system, the higher my incident energy. Because my instantaneous pickup on my breaker has to be higher than the three-phase bolted fault. And the arcing faults are going to be huge in clearing time. Oh, Alan's priorities: reliability. All right, here we go. Safety, performance, reliability, safety, performance. I love it. Cost effectiveness, efficiency. Reliability. I gotta write these down. Ease of maintenance. All right, I gotta write this down. I love this. I love it. All right, so here we go. Alan. Reliability. Reliability. Safety. Performance. Cost effectiveness. Cost effectiveness, efficiency, ease of maintenance. Efficiency, ease of maintenance. Cost effectiveness. Environmental impact. 1, 2, 3, 4, 5, 6, 7, 8. All right, so let me do this, Alan. Let me show you something. Where's my PowerPoint slide deck at? Oops, I did something. Hold on. I don't know where my PowerPoint slide deck is. All right, so here's what I'm going to do. Home, I'm going to put a new slide in, Alan, and I am going to take your list because I want to talk about this one because I'm in your court here. Because we could make some arguments, and you know me, I love to argue. Well, at least my wife thinks so. Prioritization. We'll call this goal prioritization. Prioritization. I can't spell. All right, let me hit this and go back to this. All right, So buttons on your underwear, right? We have reliability. I like this, Alan. Having said that, I buy cast coil transformers instead of liquid transformers. Ooh. Environmental impact does drive some decisions. You're right. And here's my thing, Alan. Here's my thought process on this. We could sit down, cost effectiveness twice. Cost effectiveness. Oh, yeah. Well, then we missed one. What did we miss? 1, 2, 3, 4, 5, 6, 7, 8. We got 8. I got 8 goals. Reliability is there. Efficiency is there. Safety is there. Cost effectiveness is there. Twice. Scalability. Scalability, Alan. That's what we missed. Scalability. And I would argue scalability is future growth. So I'm going to take the second cost effectiveness out. And I'm going to replace that. I'm going to do this. Because this is the kind of guy I am. Here, you know what I'm going to do? I'm going to move this over here. I'll move this over here and just do this. All right, so I'm going to take cost effectiveness out, Alan, and I'm going to put in scalability in its place, right, wrong, or indifferent. I'm just going to do that. So now here's my thought process, Alan. I can say reliability drives safety depending upon your process. Like I said earlier, if my process when it goes down can kill people, then reliability is safety. So I look at reliability and safety almost as a parallel. I really do. I would almost say, here's what I would say. I would do this: reliability and safety. I could argue those two in some cases go hand in hand, and in some cases they conflict with each other. Selective coordination could be one of those. So I got to take this out. I'm undoing that. I'm arguing my way out of that. So, but reliability and safety and performance, cost effectiveness, efficiency, ease of maintenance. Then I put scalability down, and then environmental impact. But environmental impact, to your point, I could argue reliability. Somebody could say, look, I am producing a reliable power system because if I do not, I could impact negatively. Environmental. The environment. And that's where my head's at. I like your, and you know what, Nihad, we should, during our session, have the audience, OMG, put scalability in the first, cost effectiveness place. Okay. Scalability, and then cost effectiveness. We'll take this out. Scalability, that comes off. There we go. So this is one perspective of your goal prioritization. And you know what, Nihad, we could have a complete discussion. Man, I love this. I love this because you know what we can do is I can create a what's it called? It's called it's the question and answer thing. Remember? And I might have to buy a registration for the daggone thing. I stopped paying for it. It's called, can't remember what it's called, but I can do questions in, Nihad, you got to remind me what the heck that app is called. There's an app that I can ask questions and have the audience anonymously do things, and we could have them do the prioritization. SurveyMonkey. No, not SurveyMonkey. Not SurveyMonkey. Remember, it was here it is. It was an interactive presentation. Mentimeter. That's what it was. It was Mentimeter. Nihad, I'm going to log in. I know I quit paying for it. And for two reasons. One, my company has a license thing, but I don't know how to get to it. And number two, I was paying for too many. I had like 2 or 3 accounts. So, and we did this in our Power Africa. Remember Power Africa Safety Town Hall? So what I'm going to do, and Alan, thank you for your prioritization, because what I'm going to do for our tutorial, which is next Tuesday, I'm going to, what time is it? It's only 9:10. I am going to create a Mentimeter. I'm going to start from scratch, and I'll show you what I'm going to do. So here's what Mentimeter is. If you're not familiar with it, I'm going to move this. I'm going to move this over here. I'm going to move this over here. So this is my Mentimeter. I started from scratch. I can do scales, ranking. There it is, ranking. So select ranking. First, second, third, fourth. So rank, please rank. Oh, I love this. Right, Mentimeter. Yeah, please rank. Please prioritize. Prioritize the following design goals/objectives. OMG. And I'm going to go back. I'm not going to put your prioritization in, Alan. I'm going to go back to the 8. And then what I'll do is we'll test it. We'll test it right now. Reliability, efficiency, safety, cost effectiveness. Add an item. Cost effective, scalability, environmental impact, ease of maintenance, and then performance. All right, so I spelled reliability wrong, I think. Reliability, efficiency, safety. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's going to be a ranking. I don't know. 1, 2, 3, 4, cost effectiveness. All right, is it ranking? Scales, I'm gonna do ranking. So let's do this, let's present. All right, so this is what you'll do. Go to www.menti.com and add the following code: 7203 4459. So you can do this right now. Go to menti.com and www.menti.com and use code 7203. I'm going to see what this looks like. Where's my browser? I need a browser. I need a browser. I need a browser. It's over here. You know what I'm going to do? Here, I'm going to use my phone and come on, do this now. I mean, hey, come on, guys. I don't have anybody doing this, so I'm going to do it myself. Go to menti.com, 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 type in 7203 4459, join. I have joined. Now it says, please prioritize the following design goals. Your ranking. Tap or drop. Oh. How do I do this? Oh, so you, and of course, your priorities may change based on what business. That's exactly right. So everybody's answer to this question should be different. So I'm going to take, I'm taking a stab. I'm prioritizing. I'm not doing, all right, we got ease of maintenance, number 1. Cost effective, rank up, unrank options. So 1, 2, 3, let's see, cost effectiveness. So you just drag them up. Ooh. Drag them up. Scalability. Here we go. All right, I'm going to hit submit. Okay. Goals and objectives. We've got 2 people. Come on, guys and gals. Jesse Santos. Hyperscale data center. Trying to participate. Is it working? Robert from Omaha. Yeah, it's got, look. So you gotta drag them up. Drag and drop. Gotta drag and drop. And then you have to hit submit. I've only got 2 people so far. So, and now what I think this is going to do, I think this, depending upon the number of people who have put things in, this is the play thing. So we got 2 people who have done theirs, and out of those 2, this is sort of the ranking. The first is ease of maintenance, second is safety, third is reliability, fourth is cost effectiveness. I wonder if there's a way I can see how many people voted for each. I already hit submit. Must have Robert. I'm hitting thumbs up. So, but this I like, Jesse, where you're going. So that's the other thing I have to do. And what we're going to do, man, I love this. I love this. Nihad, we're going to do this for the for our tutorial. We're going to, and Robert and Alan. Yes, you can, Robert. Try again, buddy. So what I'm going to do is we're going to create a Mentimeter, so we have to capture what type of industry. And Alan and Jesse. So okay, so we have heavy industrial, commercial. Oh man. All right. New slide. Your industry may drive prioritization. Right, so we're going to capture this up front during our session. Whether you heavy industrial, I got to put petrochem in there, just because this is an IEEE workshop. Petrochemical, light commercial, and we'll do like office, building, etc. We had strip malls. Oh, I'll put light commercial, office buildings, strip malls, etc. Petrochem, heavy industrial. What else did we have? Oh, national defense. Ooh. All right. Laboratory, national defense. How about, yeah, national defense. How about laboratory? Laboratory. We had commercial, we got strip mall. Ooh, healthcare, hospital. Healthcare / hospital. Right? What else? Residential. Although I'm not sure there would be too many residential people at the IEEE electrical safety. Heavy industrial. I have heavy industrial, heavy commercial. Petrochemical, I've got lighting, commercial, national defense laboratories, healthcare, hospital, residential. Hold on, Alan's throwing out some good ideas. Commercial at hyperscale, data centers. Boom, 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 boom. Data centers. I've only got 2. Can't get back in. Do I need a new code? Cybersecurity. Ooh, cannabis. Cannabis Factory, CANNIBUS, cannabis facility, not factory. Jeez, oh man. Hold on, let me go back to this. I think I gotta go open Mentimeter. All right, let's go back to Mentimeter. There it is. Show access code, show responses, turn off responses, show joining instructions. Ooh, I can show joining instructions. Show blank screen, enable comments. I'm going to enable comments. Enable Q&A. I'll enable Q&A. Reset timer. Reset. Okay. Turn off responses, start timer. Answered. Nothing to see here. So I don't know what you would say. Oh, here, you know what I'm gonna do? I'm gonna go to Menti, menti.com. And what was the code again? The code was 723-4459. 723-4459. And I hit join. I need 2 4s. 4459. Join. Code could not be found. Jeez. 7203. Gosh, oh Ned. 7203. 4459. That's not right. 7203. 4459. 7203. 4459. That'll work. Jeez, oh man. All right, here we go. All right, so this is what you'll see. If the power system powers a chemical process where a power interruption could cause a city to blow up, you bet the power system reliability will rank high. Amen. All right, so let's say I do that. Reliability is my first choice. I'll say safety is my second choice. Performance is up there. I'm going to put cost effectiveness next. I'm going to try that. And then I'm going to say ease of maintenance, scale. So these are my last 4. Scalability, environmental impact, efficiency, ease of maintenance. I'm going to say ease of maintenance. Because if I don't have good maintenance, then Alan, that city could be leveled, right? Then I'm going to put scalability, efficiency, and environmental impact. I could argue if I level the city, the environmental impact is pretty big. So I could argue my reliability, my first 3 are actually helping reliability. I'm going to hit submit. And there it is, 4. So 4 people so far. So far the ranking is safety, then ease of maintenance, and then reliability. Ooh, man. So we got 4 players. And those are our priorities for our community. And I think I can. Sign up for free. Mentimeter is a presentation tool for those who want to listen, engage, and get ahead of the game. Help others share their opinions. Keep your audience engaged. Now, it's all what do you call it? Anonymous. So I can't tell. I know I got 5 people who voted or who did this exercise. I don't know who it was. So let's see. Alan, there is no one correct answer. Alan, you are right. On, brother. Code doesn't work. How about utilities? Oh, utilities. I'm going to throw in utility. Yes. A utility. Utility. Well, I'm going to say electric, gas, doesn't matter. Right? It's a utility. I'm loving this. Yes, we're going to have a lot of fun. And I'll tell you what, people can sign up for this tutorial. We're going to do a tutorial. So Nihad and I are going to do a tutorial at the Electrical Safety Workshop. It's Tuesday morning. For 4 hours, we're going to have fun. Nihad, it should be illegal to have this much fun. I'm telling you, don't tell my boss that I'm having this much fun, because he'll probably say you're not allowed to go, right? So don't tell your boss that you're going to join this tutorial and you're going to have a blast and we're going to learn something together, because they may not let you come. So keep up. It is legal in Canada, but we're going to be in Tucson, Arizona. Nihad, you're going to be outside of Canada. So we're going to be in Tucson, Arizona next Tuesday. I love it. Your boss is a cool dude because you work for yourself. Oh my goodness. Anyway, I like it. I like it. And I'm going to do this. I am going to, how do I escape? I just escaped from full screen mode. How do I go back to, oh my goodness, how do I get out of this? Reload page, show frame source, reload page, print frame. So I'm just saying, I'm going to close that. All right, I'm going to close that. Now I'm back. Oh, look at this. Look at this, Nihad. There's a QR code, baby. People can go like this on their phone, put the QR code. I'm going to try it. Okay, I hit Menti. Oh, and it takes you straight to the app. This is the cat's meow. And you can comment. Look at this down here on the bottom. I can disable comments. I can go here. No questions from the audience. You can add questions. So I'm going to come to this and I'm going to scroll down to the bottom. I can hit the thumbs up. Boom. I got a thumbs up, and I can hit send a comment. And I'm going to say, I'm going to put the 2 hearts. Comment sent. Oh, look, I got hearts. Send a comment. I love Tom and Nihad and their presentation. And I'm going to hit send comment. Boom. Look at that. It's down there on the bottom. Oh my goodness. Disable comments. I got 1 thumbs up. I can ask a question. I'm going to ask, send a comment, open Q&A, add a new question. How are you so awesome? Submit. All right. So let's see what it looks like. I have a comment down here on the bottom. See it right down, right down there. I click on that. How are you so awesome? And then I can, and look, I don't know who asked it. It's anonymous. Press enter to mark as answered. So I would answer this. I would just say, look, I don't know how. It was from birth, I guess. I don't know. God gave the gifts, and I'm just capitalizing on it. So I don't know what to tell you. I don't know who asked the question, but thanks for the question. It really means a lot to me, and it was probably Alan. Thank you. I know Alan. You're awesome. Or maybe it was Nihad. I don't know. Could have been Steve Spiek. Good morning. Often a client specifies code implying minimum, and the priority is cost. I agree, Steve. That is so true. And they'll say bare minimum requirements, because remember, the code is the bare minimum. Jesse Santos. Oh, this was a good session. So you guys are helping, contributing. Remember, next week is the electrical safety workshop. We will be, myself and my friend Nihad El Sharif, are going to be, I'm going to leave this up because you can use the QR code, and this will be live. So I'm going to leave this up. If you guys, if somebody's watching this later on today, this will be available. So take a look, take a picture of the QR code and enter your prioritization for our eight design goals. All right. That can be very much competing design goals. So please take some time and prioritize and contribute. So, and hopefully we'll see you at 12 o'clock today Eastern on IAEI News Live, where we're going to talk about this topic. And we're going to be referencing code requirements because the NEC has goals and objectives that will compete with your design goals and objectives. You're going to either have to compromise or you're going to have to come up with ways to achieve what the NEC tells you to achieve, what your customer is telling you you need to achieve, what the application is going to demand that you achieve. This is going to be a fun discussion. And we'll throw up the prioritization as well. What are your priorities? So anyway, I have to get back to making my slide deck. Can't get back in. Should be able to get back in. It was definitely a cute question, not me. I did not log into Mentimeter. Oh, Alan, I love you, brother. Awesome. All right. So the Mentimeter stuff will be up there. If you feel rambunctious for watching this video later on, take a look at that QR code. Go to menti.com, enter the code 72034459. That will be, so I'm going to do this real quick. I am going to do this because this is what I do. How do I add text? Freestyle, Menti. So the text is www.menti.com and the code is 72034459. That's it. There you go. Go up to this code, go to menti.com, enter that code, and put in your prioritization of the goals and objectives. There's 8 goals and objectives that can be competing goals and objectives: reliability, safety, performance, scalability, efficiency, ease of maintenance, cost effectiveness, and environmental impact. What are your prioritizations? I'd love to hear from you. So go ahead and get her done, and I appreciate it. Thanks for spending a few moments with me this morning as I am preparing for my presentation. I've got some meetings coming up in about an hour, so I have to get stuff done. Thank you for all that you do for the industry. Thanks for what you do for electrical safety. Remember to stay safe, and please, after you drink your Buc-ee's, if you are from Texas, this was sent to me from a friend of mine. Jody Wages, thank you, Jody, for sending me my Buc-ee's Yukon Outfitters coffee mug. So go make yourself a good cup of coffee. Oh, look, a friend of mine when I was in Costa Rica gave me some good coffee. Look at that. That's Reserva. It was delicious. It's ground coffee. I'll tell you what, you open this bag and look inside. Man, I just love the smell of this coffee. Anyway, I need to order more online. That's for daggone sure. So good Costa Rican coffee. It was good. We got 6 people now. 6 people voting. Get out there. Go up to menti.com, 7203-4459. Prioritize the goals based upon you and your, I don't know, based on your project, the business that you're in, the industry that you're in. Let us know your prioritization. We got 6 people. Let's take a look at the results so far. Safety still first. Reliability is second. Ease of maintenance is third. Performance is fourth. Cost effectiveness is fifth. Scalability sixth. Environmental impact number 7, and 8 is efficiency. So I got another comment. How awesome are you? So how are you so awesome? Oh, I'm gonna hit enter and mark it as read. Answered. There we go. I can disable comments. What's this? I got 2 thumbs up. All righty. I'm going to leave that up, guys, and I am going to run. So thank you. Take care. Oh, Alan, if the power system powers chemical oh, wait, we already read that one. Alan did not log into Mentimeter. So it was not Alan who said, why am I so often? You know, awesome. You know who did? I did. All right, guys. Thank you. Take care. We'll see you at 12 o'clock Eastern today on IAEI News Live. Stay safe, everybody. I'm going to hit me end. What a good session that was. Man, what a good session. That's why we do it. That is exactly why we do it. We had some good comments from Alan and crew. We are going to have a very good tutorial. All right.